importance of to give out a valid result. Why in our daily life, no matter you are in the testing environment or not, we really rely on having a valid result in every industry. So if you remember, last week we have talked about what's the purpose of having the valid result, right? So we would like to have some confidence on the result, okay? So, and we rely on the result, but first of all, we also have to select a method. So when we think about a method, we have several items that we have to be considered. Can anyone remember what we have touched on when we have to thought about how to choose a method? Several points we have to consider, but I'm not saying that every point is very crucial, but you have to be considered as a laboratory supervisor or as a boss, because each of these items will affect the outcomes or the sample amounts that you can handle, the cost, etc. Okay, so can anyone list out what I have been touched on about the items that we have to be considered when we think or about a method? Can anyone test in the text box, chat box, please? Anyone? So first of all, do you remember I have talked about the ease? So people would like to touch on the easiest procedure, right? So if you have a choice with the similar or the same accuracy or the instrument that you have, then you may go for having a more easy method when you choose your method for your testing. So I saw some one student the cost is also an item that we have to be think about because sometimes you have to invest on some of the instruments or some of the expensive chemicals that you don't have in the laboratory, right? So when you buy a new instrument, you have to think about whether it is worth to buy it or not. It is not only think about just to buy a new piece of equipment, okay, then we don't care about the other things. I have also mentioned about when you invest a piece of instrument, you also need to have the man that could support how to operate the instrument, right? So as a whole, you have to think about it when you decide the method as well. Okay, so this is some of the points that we have to think about. And also we have talked about the safety. So because you have to equip some appropriate protective tools for your staff in order to conduct your experiment. So, and such as if you will need to handle some dangerous or some hazardous chemicals, you need a film cupboard, right? And also some gloves, which is very common in the lab. And also maybe you have to have some face shield if there are some handling of the explosive materials, okay? So all of these items you have to think about. Of course, you may have some others, as long as you have a look on the overall views, then you have to take the balance between whether you choose a fastest method, but with a higher cost, or the slowest one with the less cost, okay? So I have talked about this one last week. So are those words that have been written on the whiteboard very is clear or not? Because last time some students said it is not very clear. I hope if it is clear, then I will use the size of this word that I have just written. Okay, so besides, we have talked about how to what items that we have to think of, and we also have mentioned about another important parameters that we have to be think about when we design the method as well. Do you remember the 4M and 1E? Can you name out those M and E to me? So the first one I can give you is the man. Okay, so you have to hire the competence and with the experience persons to support your method in order to provide a valid result, right? Another one that's great. You can also mention the machines. Yes, because we have the machines in our lab to support the test. But before you use the machines, and do you remember what I have been taught about? Before you use the machines, you have to do some checking on your machines, okay? So I hope you will still understand and remember, okay? So the next M, yes, you have already mentioned, some of them mentioned, is about the method. Okay, the method needs to be approved, okay? Make sure that it is an approved method, okay? And then the last M is material. So make sure you use some reputable materials, and maybe you can buy those from the some international reference standard, and or with the high purity of the reputable suppliers. Okay, so I will recommend to use the certified reference materials. Okay, so you can be more sure on the purity of the standard, and the results will be more reliable. Okay, so those are the 4M. Okay, and it is very obvious and straightforward. The E is the environment. Okay, so make sure that you have an environment that is fit for your experiment. If you need a warm or some well-controlled humidity room, then you have to be sure that your lab can support, because some of the materials or some of the analytes may be sensitive to a particular environment. Okay, so be sure that you will have a good understanding of the properties of the analytes that you are going to analyze. Okay, so and ready for the environment to carry on the test. Okay, you don't want those environments to affect your results. Okay, so this is also the parameters that we have to be aware of in order to provide a reliable and valid result. Okay, so for the method, I have also talked about you can use the standard method, or some in-house method. Okay, so the standard method that you can obtain the entire step-by-step procedures from some of the international organizations, okay, such as ISO, BP, USP, ASTM, etc. Okay, so you can follow all the steps that they have been stated in their compendium or in the monograph. Okay, for the in-house one, you have to design on your own. Okay, so you have to do a lot of research. Maybe you can extract some ideas from the standard method, but because it is not very straightforward that you can be used in your analyte or your laboratory, then you have to redesign the entire procedure or some setting of the instrument. So this is the in-house method, okay? So regarding the standard method and the in-house method, to support it, we have to do some method validation and method verification, okay? So last time we have taught some of the definitions of the method validation and the method verification, okay? So these are the key items that I have been talked about last week, and I hope you can remember and understand it, okay? So tonight we will move on to talk about the method validation, okay? So why the method validation is very necessary, okay? As we have talked about last week, a lot of tests in order to have a reliable result, there are million tests, measurements, and examinations in our daily life, right? For example, to value the goods for trade purpose, to support the healthcare, etc. Okay, or maybe to perform some surveillance of the environmental parameters as well. So each of these aspects in our society is supported in some way by our analytical method, right? So the analytical method is the method that we choose will be very crucial, right? So the method we choose, but we have to prove, we have to show the confidence of our result as well, okay? Not only we just have the materials, etc., but we will have a validated method, okay? So sometimes you carry out the testing costs, right? The testing costs in the measurement may be high. Sometimes, so do we want to waste our high cost measurement? No. So in order to have the confident result, we don't mind to do some extra work on the method, just as the method validation, in order to have the confidence to our customer or to the other service provider or servicer that we have a reliable result to show you, right? So it is very important that we have made the correct measurement and with the reliable result, okay? So that's why the method validation is such that important, okay? The customer can trust our reports, right? And also as a lab chemist or as a professional staff in the testing industry, we also has this responsibility to justify, to provide this trust, okay, by providing the right analytical result, okay? So that's why we would like to spend some time to do our method validation before we use this method, the method that we find or the method that we use in our routine use for the release of the result to our clients, okay? So this is some of the issues, some of the items that we have to be considered. And tonight we will talk what kinds of the items that we have to be touched on when we perform the method validation, and we will go for it one by one, okay? So the method validation study gives some additional benefits to the lab, okay, undertaking the validation, okay? It also provides a solid knowledge and experience of the practical details of performing the method. So including what kind of things that we can be aware of such as we will note about some critical steps in the process, okay? So during the method validations, we will do some parameters, some items, okay? So we will note what parts or which parts it's very crucial, okay? We have to take notes in when we do the method in our daily life or in our routine use purpose, okay? So the validation will give the labs and the employee a greater confidence in their own results, okay? So to highlight the method validation, I use the abbreviation of MV, okay? So to have the confidence, okay? To make sure that the confidence to our customers, okay, and also for chemists or for the laboratory, we also need confidence, because once we have confidence on our method, then we can show that, or we can let our customer have the trust. Okay, this is the lab chemist. Okay, so and make sure that the result that you gave the customer is reliable. Okay, how to prove that? You have to do the method validation with then you can, your customer can trust your result, and we can say that the result is reliable. Okay, so I hope you all understand. So also for this part, I have this set of the notes for the undergraduates and another supplementary notes for the MSc students. So please have a look on those supplementary notes for those MSc students. Okay, so now we have to talk about what kind of characteristics that we have to be considered in the method validation. Okay, so first, I will talk about it one by one. Okay, so the first one is about the specificity, or sometimes people may say selectivity. Okay, so the selectivity or the specificity are sometimes interchangeable, okay? Okay. So these terms is refer to the extent to which the method can be used to determine the particular analytes in a mixture or matrices without interference from the components of the similar behavior, okay? Okay, this is one of the definition about the selectivity. Okay, so so make sure that it will not be interfere without interference from the other similar behavior analytes that you have in your mixtures. Okay, so you have to detect what you would like to detect. Okay, so later on I will talk it one by one how to perform the selectivity in the method validation. So this, first of all, just would like you to note the definitions about the selectivity and the specificity. So the first one, we have talked about, then we would like to go to the next one. So the next one is accuracy. Sometimes people may say truthness, okay? The accuracy is to talk about the closure of the agreement between a measured quantity valued and a true quantity value of a measurement, okay? The measurement is to be accurate when it offers smaller measurement errors, okay? So with a smaller bias that we have, then we can for sure that we will obtain a more accurate result, okay? So in the method validation, we have to conduct these characteristics in order to prove our method with a high accuracy result. So it's between a measurement quantity with a true value, okay, versus the true value. Okay, so and also we have to be ensure that we will have a smaller measurement error. Okay, so this is with about the accuracy. Okay, so we will have a procedure on how to prepare the accuracy, or some suggestions on how to perform the accuracy characteristics in our method validation. Okay, so we have talked about the selectivity and also the accuracy. The next one will be the limit of detection. Okay, so the limit of detection is the level that we have to be detected, okay, as one of the points that we can measure the values, okay, is larger than the uncertainty, okay. So the abbreviation is LOD, the limit of detection, okay. So actually it's a point or a level, okay, that is with in this level or this point, so it is we will have a value, okay. This value is larger than our uncertainty or our the confidence, okay. So we have to do the detection limit in our method validation as well. Okay, so usually apart from the LOD, people will also do the LOQ, which is the next point of our method validation characteristics. That is the limit of quantitation. Okay, so it is the lowest concentration test level that we can quantify, okay, such that we can identify our analyte, okay, in that also can be proven with confidence, okay, and with an acceptable mean recovery, and also with an acceptable relative standard deviations in this LOQ level, okay? So we have to do some recovery in order to ensure that we will note the provide a confident LOQ. Okay, so these two will be also talk about later in after we have list out these characteristics. Okay. So the LOD is just to have a level to be detected. Okay, you don't need to do to confirm by doing the recovery. Okay, but for the LOQ, you have to do some extra testing in order to for sure that your level to say that quantified values is the limit of your quantitations. Okay, at certain level, this level is the LOQ. Okay, that that level that we have to be confident that the samples we can detect it with that exact amount. Okay, that is a certain mg amount. Okay, we have to be for sure in order to provide this value. Okay, so usually the LOD is much lower than the LOQ, because for the LOQ you have to do some extra spiking or some handling in order to provide the LOQ values. Okay, so in some of the guidelines we'll talk how to perform the LOQ and the LOD. Okay, for the next one is about the linearity of the response. Okay, so for the linearity of the response is about the working range of the calibration curve. Okay, so the linearity is the ability of the method to obtain the result that is proportional to the concentration. Okay, the linearity is also have the ability with the given range, okay, to obtain the test result that is directly. So usually in the testing or in performing the method validations, the linearity will have the several points. Okay, you have to plot the graph. Okay, see whether it is linear or not. Okay, so and we have the signals on the y-axis and the concentration level on the x-axis. Okay, see whether it's what kind of properties. Okay, it depends. Okay, so later on we will also talk about ideally we will be having the proportional concentration. Okay, the signals will be proportional to the concentrations. Okay, so and it will have a certain range. Okay, depending on your sample concentrations. Okay, so you will have to obtain the linearity to see the properties of the signals versus your concentrations of your standard. Okay, so this is the linearity. Okay, so and for the next one is about the recovery. Okay, so recovery is having some spiking on the samples. Okay, to similarly to the accuracy. Okay, you have to test your measurement values versus your true values. Okay, but here you have to to focus on the bias as well. Okay, so for the next one after the recovery will be the precision. Okay. So for the precision, we usually will have two items, which is the repeatability. Usually it's performed in the own laboratory, okay, within the laboratory. And so what's the repeatability is? It's the closeness of the agreement between the mutually independent test results obtained with the same method on the identical test materials in the laboratory by the same operator using the same equipment within a short period of time. Okay. So you have to be, for the repeatability, you have to note that it is with the same lab. Okay, so usually it's the same operator, okay, with the same equipment in the short period of time. Okay, so this is the repeatability in performing our precisions in the method validation program. Okay, so besides the repeatability, we have another so-called reproducibility. Okay, so the reproducibility is the similarly cases as here, but we have to perform the method by using the different conditions. So as mentioned here, you have to use different batches of sample, okay? Choose another operator to perform it, okay? And use not use another reagent. Maybe you have to use the, actually, if you select, let's say methanol as a solvent, you also use the methanol, but maybe you choose another date of prepared of these reagents, okay? So, and all those the standards, and also some other instrumentation settings that you can be various, okay, to vary your parameters when you perform the reproducibility program, the items in your method validation, okay? So some of the laboratory, if they can ask other laboratory to perform the validation for them, if it is available, then it is very good to have the inter-laboratory result to support the reproducibility, okay? For the precision, we have repeatability, okay, and also the reproducibility, okay. So for the next one is on the method validation characteristics, we have to be consider the robustness, or sometimes we call ruggedness, okay. So this test, what can we perform in the validation about the robustness and the ruggedness? So we can what's about the robustness? Okay, it's a measure of its capability to remain unaffected by some small and some, but it is some deliberate variations method parameters. And it will provide an indication of the procedure's reliability during the normal usage, okay? So later on, when we talk about this bit by bit, and then we will talk what kind of parameters that we can change when we perform the robustness in our method validation, okay? So okay, so it is unaffected by small but deliberate variations in our method parameters, okay? So depending on what kind of instrument or what kind of items that you have used in your method, then you have to have a slight change on that, okay? So we will discuss it later when we go through it, each items later on, okay? So this is the robustness, ruggedness, okay? So for the next one is about the uncertainty. For the uncertainty part, Dr. Wen will cover it. So I won't go into details on that. Okay. So but you can also consider this in your method validations when you perform some of the calculation. Actually, the uncertainty is the parameters that associate with the result of measurement. Okay, so that will characterize the dispersion of the values. Okay, and could reasonably be attributed to the measurement. Okay, so and it will involve some of the calculations with some of your standard deviations, etc. Okay, so for details, Dr. Mac will go for that, but for the undergraduate students, we will just note this terminology, then it will be fine. Okay, so for the next one is about the stability. In the pharmaceutical industry, we will perform these characteristics when we will consider these characteristics when we perform the method validations. But it is not only applied to the pharmaceutical industry. As long as you think that the stability is very important for you to be considered in the method validations, no matter you're handling some toys or some other sample matrix, then I think it will be also useful to detect or to study the stability of your sample and also your standard in your method validation. So to give you a better understanding about the properties of your sample and also the standard. Okay. So the above are the characteristics that we have to be considered in the method validation. Okay, so so we have a lot of the characteristics, but are we going to perform all of this? Okay, so this in here we have a table to show that some of the recommended performance characteristics that you can consider in different scenarios. So the left-hand side, I have listed out those characteristics that we have been talked about. Okay, and in the screening or the qualitative method that we have to be conducted, some parameters, characteristics that we have to be considered, such as the selectivity, accuracy, and the limit of detection. So because we just need to know the presence of a particular analytes. Okay, so we are not very clear about the quantity, the level, the exact amount. Okay, so first of all, we have to make sure that our method can detect what we would like to detect, the analytes. Okay, so it must be specific and needs to be accurate as well. And because just like in the screening, whether it is the presence of some banned, let's say banned drugs or etc. Okay, so we would like to note what's the lowest level that we can detect it. Whether it is very, very accurate or not, it is not very important, but at least we should show our method would be able to detect that particular analytes. Okay, so we will consider these three items in our method validation. So for the right-hand side column, if you have to do the your method is for quantitation purpose, that means you have to calculate the exact amount of your analytes. Then if your method is in-house, okay, so you have to consider maybe all of the characteristics that I have been mentioned just now. Okay, so in this table, it's just give you an idea or some recommended parameters, characteristics that you have to be considered. But I would also suggest you to perform some risk-based analysis in your laboratory whenever you perform the method validation, okay, to evaluate and to determine what exactly the characteristics that you have to do, okay. This table is a reference, okay. Sometimes when you perform the some risk-based testing, some risk-based analysis, okay, so you can prioritize what kind of characteristics that you have to be performed, okay. And sometimes maybe you have, apart from these parameters, characteristics, maybe you have to do some extra, okay. Sometimes after you perform the risk-based analysis, you evaluate after the evaluations, okay, then maybe you can delete some of the characteristics, okay. But in the risk-based analysis, so you have to give some justification, okay. It's not just say, I don't want to do this, and then I don't want to do that in our method validation. No, you have to consider, is there any impact on that? Okay, so there are one of the analysis tools that you can use is called the risk-based analysis. Okay, so there are many tools in performing the risk-based analysis. Okay, so this is one of the tools that is so-called the failure modes. Okay, the failure modes and the failure modes and effects analysis. Okay, so this is one of the tools when you do this risk assessment. Risk assessment tools. Okay, so this is one of the risk assessment tools. So in this FMEA, they will suggest you to evaluate several items: severity, occurrence. Severity is it if we don't perform this, just an example, if we don't perform these characteristics, is it severe? Okay, you have to do some justifications or to have some findings on that. Okay, and the occurrence. Okay, the risk or the probability to have this to be occur, is it very high? Okay, and the next one is we have to have the detection of the risk. Okay, the probability occurrence. Okay, okay. So this is the risk-based analysis tools that you can consider. There are a lot of other assessment tools. You can find a suitable one for your laboratory when you perform the method validations during choosing which performance characteristics need to be performed. Okay, so this table is just an example for you. Okay, so and now I list out a scenario in a pharmaceutical industry for you to evaluate what kind of the method performance characteristics that you have to be consider when you perform the validation. Okay, so the characteristics may be the selectivity. So the first one. The second one is the LOD. Okay, and the third one is the LOQ. The fourth one will be the linearity. The fifth one is the accuracy. And the final one is the precision. Okay, so this is the characteristics that I have talked about just now. Okay, so so just for in the ID, so I just need to do the identification in handling my pharmaceutical samples. Okay, so in some cases, we'll just recommend you to perform the selectivity in the method validation. Okay, so if you just need to show the presence of a particular drug analyte, okay, because in the QC laboratory, because you noted the production, the products, the amounts that they have, so they just so you just need to use a method that can detect that analyte. Okay, so you just need to do the selectivity. Okay, but for sometimes if you need to do some quantitation test for the impurity in your product. Okay, so sometimes if you need to do the quantitation of the impurity. Okay, so in your drug products, you have your main components. Let's say nowadays people will go for the Panadol. The Panadol will have the paracetamol, which is the active ingredient, the ingredient that can help you to cure your fever or your sore throat. Okay, to relieve your pain, right? But in the drugs, it will have some impurities. So that is not only presence of the paracetamol. It will have some other impurities in the drugs. Okay, so if you have to have a method to be ready to detect the impurities, so we will have to consider in the method validation, we have to consider the selectivity because we have to find a method that can detect that particular impurities. Okay, and because we consider the quantitation, that is the level. Okay, and usually the impurities will have a very low level. Okay, will not be dominant. Okay, otherwise when you take a pills of Panadol, actually you take impurities instead of taking the active ingredients paracetamol. Okay, then that's not worth, right? So the level should be low, and we have to think about to perform the limit of quantitation because we need to find out the exact values that we have in our pills about the impurities. Okay, and also we have to consider the linearity, obvious the accuracy, and also the precision when we perform the method validation, okay? But if we just need to do the ID, the identification of the impurities, that means just the presence of the impurities. Of course, the selectivity we have to be considered, right? But the other items that I have put a tick from 3 to 6, we don't need to be considered if we just perform the ID, but instead we have to perform the LOD, okay, to make sure that we have that particular low level, okay. In here is the ID of the paracetamol, the active ingredients, okay. So that is the core of the drugs, okay. But this here is the impurities, okay. So because we would like to note the levels of what we can detect, okay. So we have to consider the LOD. So regarding the quantity of the paracetamol in the drugs, okay. So the quantity of the paracetamol, then we have, because as in the pharmaceutical industry, because you have the production line, you note how many milligrams that you have been put into the manufacturing process, okay. As a QC, you just need to verify is whether they put the correct amount of the active ingredients in the process. The ultimate quantity of the active ingredients paracetamol is in that particular pills, okay. So in doing the method validation, of course, we will include the selectivity, okay. And because as a routine purpose, we note we just need to do the linearity, accuracy, and the precision in the method validation. If we are in the QC laboratory in the pharmaceutical industry, okay. But this is also just an example, as I've mentioned. This is recommended, okay, in the USB, but it also stated that you have to conduct the risk-based assessment analysis on your own by your laboratory before you really consider these characteristics to be taken in your method validation, okay. So maybe we take a break here, okay. So we will come back at 8:10, okay, come back at 8:10. So, and then we will continue for our rest of the topics, okay? See you at 8:10, okay, 10 minutes past 8. Testing. Okay, so let's move on to the next one. So regarding the method validation in the HOCLES, it also have some requirements on that. Okay, so let's say, for example, for the first one, specify the grade of the reagent used, including the water. So the water requirements, the level that you have to use in your method validations, that means in the routine purpose, like in the routine use later on, they will suggest you to use a particular grade 3 water level if you perform some of the toys testing according to the HOCLES requirements. Okay. For the second is in the HOCLES requirement, it also mentioned you have to strictly adhere to what the standard that have been mentioned to for the intended concentration ranges and the sample matrix in your test method. Okay, so you have to stick on that. And for the next one is to verify your competence by performing the test using the certified reference materials, and to recommend you to perform some proficiency test if those test programs is available internationally. Okay, so later on, I will talk about a little bit about the proficiency test. Okay, so it will be conducted at a certain time interval to show when you perform this proficiency test. Actually, the proficiency test, you will have some provider to have some sample matrix that is similar to what your laboratory would like to conduct. Okay, so you have to find it out on your own. Okay, let's say if you conduct some food testing on a particular matrix, then you try to look for that kind of samples in the proficiency test programs. Okay, it may not be available in sometimes on your specific matrix. Okay, but if there you can find it in the some organizations. Okay, then the HOCLES will recommend you to participate in this kind of proficiency test programs. Okay, and to show this kind of the proficiency test program actually would help you to note more about the performance of your lab. Okay, to compare to the other laboratory in the worldwide. Okay, so it has a large sample pool. Okay, and then you will note your result compared to the other laboratory in the world. Okay, so it is worth to participate in its proficiency test if your lab is have some method that is under HOCLES approval. For the next one is more advanced than that specified in the test standard may sometimes constitute a deviation. Okay, so in some of the tests, the standard test method, they may be sometimes will stay some old kind of equipment. Okay, but maybe sometimes in your lab you will have some advanced instrument. Okay, so with the use of the advanced technique, then the one specified in the standard method may sometimes will contribute a deviation. Let's say, for example, if in the GC gas chromatography, some of the standard method may recommend you to use packed columns. Okay, but in your lab, maybe you have another capillary gas columns. Okay, so although we noted that it is acceptable to use the capillary columns because it gives better resolution, right? But it will also have less susceptible to possible interference, okay? But the test result sometimes we obtained may not be comparable with those we use in the PEG columns, okay? So if the lab, if you modify some of your techniques, so you may also need to assess whether it is without any deviations and it will not affect your test result. So you have to provide some evidence to support it, okay, in your validation, okay? So that's why we will perform the validations if we not follow the exact instrument that we follow in the standard method, okay? For the next one, sometimes we have to do some confirmation on the identity of the organic compounds, okay? So this kind of confirmation is required for, let's say, some of the non-selective methods, okay, such as in the GC when we're using the ECD, the electron capture detector, or some FID, okay? So so you may need to use different detector or in order to confirm the identity of the organic compounds, okay? Because sometimes just one detector method may not be sufficient, okay? So you have to list out in your method validation in order to, and also to be documented, okay? And some of them will be required. Let's say in the liquid chromatography, maybe have you heard about the ELSD? Okay, the evaporative light scattering detector. Okay, so and also some of the detector, for example, the refractive index detector, it is also in some not specific to a particular analyte. Okay, so you may to do some confirmation by considering the other, using the other methods or using the other detectors. Okay. So, and for the next one is limit of detection, quantitation, and the reporting should be suitably verified. Okay, so when you perform your validation, it will recommend you to consider these characteristics if you are under the HOCRES approval laboratory. Okay, and for the next one, the method bias shall be assessed using the matrix reference materials or some recovery studies by using the standard reference method, okay? This kind of the method bias needs to be assessed with the use of the certified reference material if it is available commercially, okay? So it will you can see that it is very important to use the certified reference materials, okay? So if sometimes you don't have the certified reference materials, you may need to use the recovery studies or sometimes comparison with the other high purity, high quality of the materials, okay, by doing some spiking on your matrices, okay? So you have to design in your validation. And also, HOCRES also remind you to review and revise the performance characteristics of the test methods on a regular basis. So the method validation is not just performed once, okay? Let's say if I perform the method validation this year, as it can be no need to be validated afterwards. No, it depends on the performance of your data in the daily life. Okay, so sometimes people will plot some control chart to check your performance of your daily samples. Okay, to see that is there any deviations, or is there any problems on the method? Okay, sometimes it's not due to the samples, maybe it's the method itself have some issues after running for a long time. Okay, so the laboratories need to evaluate and to review it regularly. Okay, so just now in point 3, we have talked about the proficiency test. Okay, so the proficiency test is very essential. That is, you have to be considered in your laboratory in order to provide a good quality result as well. Okay, it's very essential. If you have a quality assurance department, they will usually ask you, the laboratory, to participate the proficiency test program. Okay, so it is an independent proof of competence for the regulatory bodies and customers. So when the hawkless come to perform the audit, they will ask you whether you have participated the proficiency test or not, program or not. If you did, then it will have shown some of your lab competence, because by using the test results in the proficiency test, it will show your lab performance. Okay, so it is worth to perform it. Okay, sometimes it will be expensive, but I think as a whole, it's worth to contribute some time to ask your analyst to conduct the test. Okay, and it is relevant to all the testing lab for quality and safety in every country, and also for the in the participation of this program, it will provide an independent feedback on the quality of your results. Okay, which will let the lab to have the chance to monitor the lab performance, and also you can review your data and to look for any improvement in your lab. So it's not just a one-time activity. Okay, it's not just get a result, then it's done. No, I will suggest you to perform regularly. Okay, and how regular that you need to perform, it depends on the first one. Is this available? Because you have to check the organization. Okay, it may have this year, but may not be launched for next year. Okay, may not be held next year. So you have to check it regularly. Okay, and then if you have the time in your laboratory, okay, then you have to participate in that program. Okay, because you can have the regular review on your performance. Okay, whether for the first time, maybe, oh, I get a little bit deviations from the pool of the samples in the world. Okay, then maybe I make some adjustment. Okay, we defining some procedures or other things in the procedure or in the instrumentation setting, etc., or in the sample preparation. So whether it is efficient or it is have the good performance after we adjust our setting, we don't know, right? But if for, let's say, a period of time, let's say next year, okay, if there has the similar programs on our sample matrix, then we also participate and we will get the result again. Then the lab manager can compare the data from the last year or for the last participation, then we can note more about the our performance. Okay, of course we will go for the improvement, so that's why we would like to do the testing program again and again. Okay, so in the after we perform the testing, the provider will provide you some data. Okay, so the performance evaluation, the majority of this proficiency test scheme involves some form of performance score. Okay, the Z values. Okay, and the assigned value X and the standard deviation will be also determined. Okay, so they will give you the set scores. Okay, if the set score is smaller or equal to 2, it's and we can say that your lab data is satisfactory according to the, when we compare to the other lab in the world. But if it is in between 2 to 3, then it will give you a signal, warning signals. Okay, you have to look for it, whether there is some issues. And for the worst one, if the values is greater than 3, then it is so-called unsatisfactory. Okay, so this is just values for your laboratory, but the next part is you have to do some modifications or to do some reviews on actually what's caused this fail set scores that we have in our lab. Okay, so we have to evaluate and do some adjustment. Okay, so the accredited laboratory needs to define which PT schemes that we have to be enrolled and how often. Okay, so the laboratory should also define the level and the frequency of the participation after the careful analysis. So when you evaluate how often and how frequent that we perform the proficiency test, you may think about these. Let's maybe the method development and the validation work. Okay, and also the experience from the reference materials and the characterization studies. You can evaluate these items to see that how often that we have to participate in the PT programs. Okay, let's say if we have participate some other interlaboratory comparison very often, then maybe after evaluation we may say that oh, the frequency of performing the proficiency test we will this year maybe we will be lower because we have participate other international laboratory comparison already. Okay, so and also from the data of the internal quality control, then you can say that oh, from the internal quality control it's quite fine, no big issues. Then maybe this year, because we have another things, maybe we have to be consider other new product method development, then maybe we won't perform this existing routine samples proficiency tests. Okay, then that's fine, but you have to be evaluate after with your quality assurance department. Okay, so maybe sometimes you also need to consider the risk assessment. Okay, by consider the following items to see whether you perform the proficiency test or not, and how frequent that you have to perform. Okay, let's say the experience and the turnover of our technical staff. If your technical staff always change by the time, then I will suggest you to perform the proficiency test in a more frequent way. Okay, so you have to risk assess on how frequent that you need to perform in the proficiency test. Okay, so this is about the proficiency test. Then the next one is there are some of the chemical test list in the HOCUS accreditations. So they will have their own documents. So if depending on which industry that you are now working on or you are interested in, then you can go for the documents. And then if it is applicable, then your lab can use the HOCUS document to follow what they state in the in conducting that particular sample and the sample matrix. Okay, so let's take one of the HOCUS documents here, and I would like to share with you. Okay, can you see the PDF now about the HOCUS document here? Okay, thank you. So this is the HOCUS standard method for conducting the chemical testing in the environmental samples. Okay, so you can see that it will list out the requirement of the personnel. Okay, and also just now what kind of training that they will recommend it. Okay, and also the requirement of the persons to conduct the test, etc. Okay, so if your method is claimed to be under this HOCUS document, then you have to follow what they stated in their requirements, and also the requirements on the performing the method validation, etc. Okay, so this is the ideas for you, that the HOCUS also have this kind of the document for you to follow. Okay. So now I will move back to the PowerPoint. Okay, so make sure that if it is applicable, then you can go for the list of the HOCUS document. Okay. So now we will go to the handling in the method validation. So how can we perform? How do we perform those method performance characteristics in our method validation? Okay, so here is the definitions, and actually I have covered it. And depending on which international standards that you are referring to, they will have some terms that will slightly different in the definitions. Okay, but as long as it will be quite similar, and as what we have in the method validation and the method verification definitions that we have talked about last week, you try to check on at which standard that you would like to follow, and then you have to check details on the definition on that in order to fulfill their requirements when you perform their the method validation. Okay. So so how to perform the selectivity in here? Some of the guidelines will have some suggestions. Okay, so in the EuroChem, they will the sample containing various suspected interference in the presence of analyte. Okay, so you will have a lot of other impurities. Not saying impurities, is other not your target analyte to be present in your samples together with your target. Okay, so you try to analyze your target one and by using your method to demonstrate whether your method can identify your target analyte. Okay, and when you perform the test, because usually I've mentioned the paracetamol as a pills as an examples. Okay, so this is your samples. Okay, but in here you will have the paracetamol, okay, and some other impurities A, B, or C. Okay, and then you throughout the sample preparation, okay, so you may use some solvents to dissolve it. Okay, in the solution. Okay, then you are going to do some analysis. Okay, but let's say you use HPLC. Okay, so when you inject the aliquot of the samples, okay, actually these samples will contain not only the paracetamol. Okay, so in the specificity, you have to inject the samples of these prepared solutions into the HPLC, and in the chromatogram, you have a lot of peaks. Okay, so you have to make sure that the interference of the other peaks will not interfere the presence of the other peaks. Okay, maybe due to the impurities A, B, C, D, etc. Okay, will not interfere. Let's say this one is your target. Okay, will not interfere the target peaks. Okay, if your method will be co-elute with the others, then it will not be a good, or it will not demonstrate a good selectivity performance in the validation. Then you have to modify your setting in the HPLC. Okay, so you have to get a very well defined and with good resolutions. Okay, in here. Okay, so make sure that you can separate the peaks in doing the selectivity test. Okay, so sometimes for the selectivity, you have to, let's say it depends on what kind of instrument. Sometimes you have to use 2 different wavelengths to confirm, right? As I have just mentioned previously, you have to do some extra confirmations for the presence of the identity of the organic compounds, okay, as required by the Hawk list. Okay, so sometimes it is necessary to perform the selectivity test by using 2 techniques. Okay, so this is just some of the examples for you. And let's say for the GCFID, if you select this technique, then you have to use 2 different columns with different polarities in order to demonstrate your selectivity test. Okay. So here it's mentioned about the instrumental detection limit. Okay, so it is the lowest and the smallest quantity of the analytes that can be reliably detected. Okay, it is not necessary to be quantified. Okay, but it is necessary to differentiate from the background, from the instrument noise. Okay, as you can see here, you will have a little bit instrument noise from the green line to the first blue line here. Okay, so this is the instrument noise. Okay, so with the presence of the target analyte, okay, so you can identify a peak in here, peak A. Okay, it is we can say that it is not interfered by the noise because it is dominated when we subtract the noise level. Okay, so this is the LOD. It is not necessary to be quantified. You just know we can detect it. This is the, okay. And later on, we talk about the LOQ, then we need to quantify what's the exact level with our confidence of this peak B contained, okay? So, and as the sensitivity increase, the instrumental detection limit will decrease, okay? So when we talk about the limit of detection, and it's the lowest concentration of the analyte in the sample that can be detected, but not necessary to be quantitated as an exact value under the stated conditions, okay? And depending on which guidelines that you will follow, and in the EuroChem, next line here, they will suggest you to perform 10 independent sample blanks measurements, okay? And then from that, you can have the standard deviations for the SAM blank values, okay? And then you can use the 3SD as your LOD values, okay? So here is the EuroChem suggestions how to determine the limit of detection, okay, with 10 sample blank. In some RUPAC, they will suggest 6 only, okay? You can see different settings in different guidelines, okay? So choose the one that you think it is applicable for your lab, okay? If you don't have a particular guidelines list to be followed, but you have a lot of choice for that. But if your lab must follow a particular guideline, then you have to strictly follow when you perform the method validation. Here is the limit of quantitation, okay? Then similar case, it will have to perform the 10 blank samples for the EuroChem, okay? But the calculations will be involved in here. Actually in here, okay. It's stated in the table, okay? So when you perform the LOD, let's say in the NATA, and usually it 10 times the LOD will be the LOQ values, okay? And for the EuroChem, it's also 10 times the LOD values will be equivalent to the LOQ, okay? But of course, once you find your LOQ, you try to use that particular level. Let's say it's 10 milligram, let's say just for example. Once you know the LOQ, you try to prepare an accuracy or a recovery samples with the use of that LOQ level to demonstrate whether you can confidently detect that particular 10 mg samples, okay? So in the HOCLAS guidelines, if you follow the food testing category, chemical testing, they will have a table, a list of recommended requirements for you. So you have to follow if you have to follow their document to test your samples, okay? If not, then it is just for reference. So apart from the selectivity and the LOD, LOQ in the method characteristics that we have to be considered in the method validation. So, the next one is the calibration curve, okay? For the calibration curve, there are a number of stages we have to be involved in doing that. And first of all, we have to plan the experiments, and then we have to make the measurements. once we make the measurement with the use of the data, we will plot the results, okay? And then from the result on the graph, whether you obtain a certain relationship, okay, then you will try to use that relationship to calculate your samples concentration, okay? And then this is the what you have to be required when you perform the calibration curve, okay? So, but in nowadays, people may ask, I know that we have to perform calibration curve in the method validation, but how many experiments that do I need to do, right? Because we don't have sufficient time or some restriction. So people may ask, what is the minimum acceptable number that we have to be performed in the calibration curve of our method validation, okay? So we have to think about normally for the method validation exercise, you have to consider at least seven standard to be prepared in the calibration parameters, okay? Okay, 7 calibration concentration. Okay, and but how this 7 concentration to be distributed? Okay, do you know how can we decide? Let's say when we perform as I have just talked about, you have to plan it. Okay, what concentration that you have to be involved in the calibration curve. Okay, so I told you we usually conduct 7 calibration standards. Okay, but how these 7 concentration standards to be distributed? Let's say I have 3 choices for you. Maybe just 2, not complicated, okay? So if you are the lab manager, when you decided your concentration in performing the calibration curve, you noted that it requires 7 concentration standards. So, and from here, you will have A and B choices. So can you tell me which one you will go for when you're performing the calibration curve? Can you type in the chat box, please? A or B for you to choose. Yeah, I saw some of you mentioned B and a few mentioned A. Okay, so why you choose B? Yes, if I am if I am the lab manager, I will go for B, because you consider that it is evenly distributed. Right? It not just focus on a particular site in the example A, okay? In B, it will be evenly distributed, okay? When you plot the graph, okay, so the points will not just focus at here, okay, it will be scattered among a full range, okay, then it will be more reliable on the signal as well, okay? So I would suggest you to first prepare 7 calibration standards, okay, and with an evenly distributed concentration range in preparing your standard, okay? And how to prepare the standard is also very important, okay? So let's say I go for, we noted that we have to get the B one, right? The B. Okay. And of course, depending on the accuracy and the working range of your balance, okay? So if the instrument is not an issue, okay, I will suggest you to prepare the standard individually, okay? So I will weight the standard for 100 ppm, 85 ppm, etc., etc. And if this is if the equipment of, or if the working range of your balance, the accuracy of your balance is supportive, okay, then I would not recommend you to prepare a stock. Then it will be diluted one by one. Why? Because any errors to be prepared in the stock will contribute the undesirable impact on the subsequent diluted standard, okay? So, but I noted that some of the lab have to consider the stock dilutions one by one, because sometimes it cannot be weighed a very low concentration level of a particular standard, okay? But what I point out here is the good practice, okay? If your lab cannot, then no choice, you have to do the dilution, but make sure that what will give you the impact, you have to make sure the man, your analyst, is competent in preparing the stock, okay? So back to my last lecture, make sure the man is competent, you have the sufficient training for your staff, okay? Because when you conduct the method validation, any errors in doing the dilutions will affect, okay? Because you have to, once the stock is very important, okay? And so that's why we will not suggest you to prepare from a common stock. And I have said the errors when you prepare the stock will be propagated to the next, okay? And any bias will be also lead to that, okay? If you have no choice, maybe you can prepare a particular stock in here, and then you prepare dilution from the stock to prepare maybe just 1 to 2 diluted standard. If it is okay, maybe you prepare another stock prime that is not the same as maybe a different concentration, okay, let's say here, then you can do the dilutions for the others, okay, if it is if your lab can support it. Of the dilutions, it's not recommended because it will it will have some errors on that, okay? So we will try to minimize on that, okay? So this is about the calibration that we have to be considered in the method validation. And in the method validation, you perform 7 calibration standards to inject into HPLC. Let's say I use HPLC as an instrumentation method. And each standard, maybe you have to, each concentration, maybe you have to inject replicates, okay? And then for each injection, maybe it takes, let's say, 10 minutes. Replicates, then maybe 20 or 30 minutes if triplicates, okay? If you inject 3 times for each levels, then in order to perform this calibration, you may take several hours, okay? It is worth to do in the method validation, but people may ask, how about the routine operation? It is necessary to perform all these concentrations in the routine. It depends on your lab. Normally, if you noted your target analyte, the exact concentrations, if you are not handling some unknowns from the customers, because sometimes you may not know what's the values from the customer's samples, okay? Then you have no choice. Maybe you need to take several concentration standards in conducting the calibration curve. But if you, as a in-house QC checking, because you note the production line, what levels that they have been input in the manufacturing process, then you noted that, let's say, I noted that this kind of samples, the food will have, let's say, 10 milligram of the certain analytes in that. I noted that. Then you can use 1-point calibration for your QC laboratory, okay? If you are doing in the QC laboratory. But for those, if you're handling the unknown samples, you don't know which exact concentration, then I will suggest more concentration standards to be prepared in building your calibration curve, okay, to provide you more confidence, okay? So for the remaining parts about the calibration, maybe I will leave it for the next week to be continued, okay? So tonight, I will talk about the calibration curve experiment up to here, okay? For the next week, I will continue to talk about the remaining part of the calibration curve and also the remaining method performance characteristics to be considered in the method validation, okay? So I hope you all understand what I have been covered tonight, okay? Take a look on the lecture notes that I have been covered tonight, okay? And we continue the lecture next week, okay? Good night.